So I think you guys don't have idea what is vectorization or text vectorization. So basically vectorization is a process of converting data, especially text or categorical data, into numerical vectors so that it can be fed into machine learning models which require numeric input to perform commutations. So basically vectorization, why is it important? Because the algorithms cannot process raw data or categories directly. So vectorizations makes the data machine readable. It also enables fast linear algebra operations, and it allows also similarity comparisons between, that is cosine and Euclidean. So there are three methods basically. So one would be back of words, BOW, and TF, IDF. So we'll be covering these two today. So before any text data can be used for classification, it is vectorized, clustering, translation, and sentiment analysis. So why raw data is not used? So the movie was, suppose for an example, the movie was fantastic and inspiring, but for you this is full of emotion and nuances. To a machine is just that it is categorized everything, and it is separated by comma. So basically the machine does not understand any characters, it only understands binary components, that is 0 and 1. So it has no measurable structure for math operations, so it cannot be compared to another sentence like cosine similarity, and it cannot be fed directly to a model like logistic regression or SVM. So vector is a list of numbers, like as you can see in the screen, it is listed. So why this format is used? Because this format is uniform in size, that is fixed length. It also allows mathematical operations like distance dot product. As far as I think, you guys must have studied vectors. If you guys are from science background, in physics you must have read about vectors and did some complex problems as well. So I think I'm pretty much clear about it. So the analogy is like, imagine if you're recommending books. To compare books, you can't just read a blurb. You need structured info like genre, author, and rating. Similarly, to compare or process sentences, we convert them into numeric summaries. So the benefit and the descriptions are, it should be the compatibility with ML. So models like SM, logistic regressions, etc., require numerical inputs. Comparability is like vectors can be compared. Example using cosine similarity. Mathematical operations, you can cluster, classify, calculate distance between vectors. And in feature engineering as well, vectors can capture meaning, frequency, and importance of words. So, so as I've told that we'll be discussing three methods. So first one is bag of words, that is BOW. It basically means that count how many times each word appears in a document. And the second one is TF-IDF. It basically weighs words based on how important they are in the document relative to the corpus. Third is word embeddings. It learns dense semantic vector representations of words that. So what is bag of words? So, bag of words is a technique used to convert text into a numerical features based on the presence of words, the frequency of words. It completely ignores grammar, word, and semantics. Think of it like a shopping list. Like you only care what items are in the bag and how many times, not in which order they were picked. I hope I'm clear. Any doubts in this?
What is semantics?
So basically, semantics refers to the meaning of words, phrases, or sentences, not just their structure or spelling. In simple term, you can say that there is some syntax, right? How words are arranged, that is grammar. Example: dog bites man and man bites dog. Both have the same word syntax, but their semantic meanings are very different. So basically, you can say that it is a simple syntax, how words are arranged. So real life analogy, suppose students submit essays, you want to check what they wrote about based on word usage. Student A says, I love natural language processing and machine learning. Student B, machine learning is fun and I love NLP. Even though both say similar words in different ways, but bag of words will focus on the word use, not the sentence structure. So in bag of words, basically count vectorizer is used. So it is basically is a class from skitlearn, and it is used to convert a collection of text documents into a matrix of token counts, commonly known as bag of words. So each column represents a unique word token from the corpus. Each row corresponds to a document, and the value is the counts of how many times the word appears in documents. So count vectorizer is used in engineering for text classification, input to ML models, and document similarity comparisons. So like first I will complete the theory, then we'll proceed to do the code part. So what are the limitations of bag of words? So no semantics. For example, love and adore are treated as unrelated. No context, bank, money, bank, river get the same weight. So it can be sparse and memory heavy with large vocabularies. So the model cannot differentiate between the meanings. Suppose the context is bank. Bank also means money, and bank also means river also, that river bank, and etc. So they cannot differentiate between it. So, but why bag of words is useful? Because email spam classification it can be used, and keyword search and document similarity basic. So, what would happen if we added the punctuation? What do you think, guys? Like in bag of words, what would happen if we added punctuation? So basically, punctuation would be treated as separate tokens unless it is explicitly removed. As I have already told that count vectorization, like count vectorizer, yes, that is correct. So it does not remove punctuation unless you pre-process the text, right? So it will treat words like hello or hello exclamation marks as different tokens. That is correct. So why might bag of words not work well for a chat box? Yes, that is correct because bag of words doesn't understand context, word order, or meaning. So which are essential for meaningful conversations. So what real world systems might still use bags of words? As I have discussed above, so give me some answers about it. Yes, correct, correct. All right, then we'll move to what is TF-IDF. So TF stands for term frequency and IDF stands for inverse document frequency. Basically, it captures how important a word is to a document in the context of collection of documents. So it together they form a weighted score that shows how important a word is to a particular document while reducing the weight of common words that appear in many documents. So term frequency, how often a word appears in a document. As you can see the formula, it is there. So for, as you can see the example, I love machine learning. Term frequency love document one, and that is like as you can see that love is occurring twice and there are 5 words. So 0.4. And for machine it is 1 by 5, so it is 0.2. So for inverse document frequency, that is IDF, as you can see that the formula is IDF is log e Total number of documents by number of documents with term T. So words like the is appear in nearly all the documents. So low inverse document frequency. Words like transformers, vectorization appear high IDF. So TF IDF score, as you can see the formula, it is, for example, I love machine learning. Machine learning is fun. I love deep learning. So basically, let's focus on the term learning. Appears in all three documents, so IDF will be low. Appears one per document, that is TF is normal. So even though learning is common, its IDF score is low due to its high document frequency. But the word deep appears only once, so its IDF is high. So for this, we'll be using TFID vectorizer. So its uses cases are email classification, document similarity, search engines, and sentiment analysis. So its advantage of TF-IDF over bags of words. So basically, when the word frequency it is there, it does, both of them does. Word importance, only it is done by TF-IDF. Common word suppression, only done by TF-IDF. And it is suitable for relevance, like a bag of words does only the basic search, but TF-IDF does information retrieval and ranking. Basically, low IDF and high IDF. So it is basically, it does not capture word meaning or context. Example, bank, that is river bank or financial bank, we don't have any idea. It is also sensitive to synonyms, that is happy versus glad. So its applications are as listed above. Document classification, search engine ranking, news clustering, keyword extraction, and so basically TF-IDF gives each word a relevance scores. It combines local importance and global rarity. Great for text classification, filtering, and search. So now we'll, like, basically the summary of this topic is like vectorization converts text numbers, bag of words frequency only, but TDF does frequency plus importance, and they both are used in search engine spam filters and recommendation. Now we'll proceed to the code. So the first one we'll be going through is count vectorizer, that is used in bag of words. So I love NLP is document 0. NLP loves me, that is document 1. And I love machine learning, that is document 2. So basically what count vectorizer does is like it tokenizes the corpus, that means that it splits into words. It also removes the duplicates. It builds a vocabulary of unique words. It also constructs a sparse matrix counting word frequency per document. So as you can see that love and loves, Both are there, right? But they both are treated as different tokens. No limitation is applied. So you can see that, right? So love and loves are treated as different tokens. Both are as are being treated as different token. So common words like I are removed due to the default token pattern. And it is also case sensitive, so everything is lowercased. You can go through it once. So, okay, now for term frequency and inverse document frequency. So for this we use TF-ID vectorizer. So basically, in this, as you can see, the so is it audible now? Is it cracking? My voice is audible or it is not audible?
It is audible.
All right. So for this, as I have told, for term frequency and inverse document frequency, we'll be using TF-ID vectorizer. So in this corpus, as you can see, I love machine learning, that is document 0. Machine learning is fun, that is document 1. And I love deep learning, that is document 2. So basically, what is TFI vectorizer? It basically transforms the text into numerical vectors using, that is, term frequency. That means how often a word appears in a document. And IDF, that is inverse document frequency, how rare the word is across all the documents. So more important and unique words get higher scores, while the common word gets lower scores. So the output is deep fun, is learning, love, machine, right? So as you can see that in row 0, I love machine learning. High high term frequency, IDF for love, machine, and learning, because they are meaningful in this sentence. As you can see, in the row 1, machine learning is fun. Strong scores for fun and is, because though is a stop word, you may want to remove it in practice. But lower score for learning, because it appears in all documents and it is less unique. So lower IDF. So, but in row 2, I love deep learning is there. It is high for deep and love, since deep is unique to this document and love only appears once. As you can see. Please go through the code.
Ma'am, can you unmute your mic if you're speaking?
So sorry for that. The So intro to word embeddings. So basically, word embeddings are the dense vector representations of words that enable machines to understand language in numerical form. So there are two types. I have unmuted myself. It is audible or it is not audible? Okay, I got it. So it is audible, right? All right. So for word embeddings, there are two types, two major categories. One is static embeddings. Another one is contextual embeddings like BERT. And for static embeddings, that is word to vec and globe. So how they work? So it learns word meanings from large corpora. It also use co-occurrence statistics or predictive models. It also produce dense vectors representations. So basically, sentence A is he swung the bat. Sentence B is the bat flew at night. Static embedding, both bat have the same vector, which is incorrect in context. So contextual embeddings generate different vectors for a word depending on the sentence it is in. So they are actually derived from transformer based models like BERT that read both left and right contexts. So they work when they use transformers to process the entire input sentences, output embeddings for each word based on its position and surrounding words. So for static embedding, right? So for static embedding, we use word to vec and globe. So word to vec and globe are classic word embedding models that produce a fixed vector for each word regardless of context. So Word2Vec is based on a shallow neural network. It uses either continuous bag of words or skipgram. It also learn to predict surrounding words. And for globes, it stands for global vector for word representation. It uses globe word count co-occurrence counts, and it also trains on a word co-occurrence matrix and factorizes it. So it also captures semantic similarity. But this embedding is static, as I have discussed. For static embedding, word to globe, word to vec and globe is used. So the word bank has the same vector whether it means a river bank or a financial bank. It is a limitation of this static embedding. For contextual embeddings, but that is bidirectional encoder representation from transformers, it generates contextual embeddings. That means representation of a word depends upon the surrounding sentence. So it uses a transformer architecture. It reads the sentence bidirectionally, in that sense, from left also it can read and from right also it can read. So it also embeds each token considering full sentence context. So as you can see that he sat by the river bank, sentence 1. For sentence 2, she deposited money in the bank. In word to vec, both bank will get the same vector, as it cannot determine whether it is a financial bank or a river bank. But in contextual embeddings, that is BERT, bank each sentence gets different embeddings based on context. BERT also understands polysemy, that means multiple meanings and syntax. but its limitation is that it is heavier and it is also slower than static embedding, but it is far more accurate. So this is the summary of this. You should go through it. Please go through this table. I am not speaking, that's why it's not audible. uh, I will show the example as well. So as you can see, Encore Web MD, it is basically that it is already pre-trained static word vectors, that is 300 dimensions. That is similar to word to vec, and NLP uh, double quoted bank, that is that processes the word and retrieves the token object for bank. As I have already stated, it cannot the word to vec, it cannot determine whether which bank it is, that is financial bank or river bank. So moving forward to word dot vector one, that retrieves the static embedding vector for bank, because it is always same regardless of the sentence or context. The first 10 numbers are shown out of a 300 dimensions. So as you can see that these are the just first 10 values of the vector representation of bank. So you can think that it is a compressed numerical signature for capturing overall the semantic meaning of the word bank. So for this vector will be identical for bank whether it is used in, like suppose for a sentence that I have deposited money at the bank, or the fisherman is sitting by the bank of the river. As I have already stated, the limitation of static embeddings, that is no context awareness. So this is where BERT and other contextual embeddings become powerful, because they give different vectors depending on the meaning of the sentence. Please go through the code. So now we will do the BERT one, contextual embedding. So basically, we will take two sentences with the word bank. First would be he sat on the river bank, and the second would be she deposited money in the bank. So for sentences, we'll use the tokenizer, and for outputs, as you can see that the code is mentioned. And first, we will need the embeddings from the last hidden state, and the first index of the word would be bank. So as we are using BERT for this, that is contextual embedding. This is the output that will be getting. So the output for he sat on the river bank. As you can see that this is a contextualized vector for bank on based on the river context. This basically focuses on geography related semantic features. As BERT takes the entire sentence as an input, it also produces a context specific embedding for each word. So the word bank will have different vectors depending on surrounding words. So as the sentence is he sat on the river bank, this embedding focuses on geography related semantic features. As you can see that. So, but for the second one, she deposit money in the bank. This is a different vector that is basically influenced by money deposit. As you can comprehend, it is bank. So it reflects a financial meaning of bank. So unlike word to vec or globe that are static embeddings, BERT gives a different vectors for the same word depending on context, making it more powerful for tasks. So it is basically understanding the meaning of the sentence, and based upon that it is taking the embeddings. Please go through the code. So okay guys, we'll end the session now, and I hope you guys are doing your project because the review for the first review it is pending. It will be done soon. So please complete your project, like start working on it, since it is a very integral part. All right then, see you guys.